So in this video, we're going to learn how to multiply two radicals together so you can find the product of any two radical expressions. So remember simplest radical form, and again we're really only going to be focusing on the first one, 2 and 3 would be for the next video, that there are no perfect squares in the radical. So we're really going to use that factor tree and pull them out. So remember that you're either in jail or you're out of jail. So remember this analogy, you need whatever the index is, that's how money that you need for it to go outside. And it's very important that you can apply the multiplying and dividing properties of numbers if the numbers are under the radical. This is a very important concept, and it's a time saver if you can get this remembered in your head. Alright, so we evaluate the given values of A and B. So we're just going to fill this chart and see if you can see the pattern between the two. So A is 4, B is 9. So I have the square root of 4 times 9. Square root of 4 times 9 is square root of 36, which equals 6. Well here, if I have the square root of 4 times the square root of 9, doing each one individually, I get 2 times 3, which is 6. I get the same answer. So on 2, I have 25 times 4. Order operations, do the inside first, which is the square root of 100. Square root of 100 is 10. On 2, I have the square root of 25 times the square root of 4. Square root of 25 is 5 times 2, which is 10. Again, notice I got the same answer. And the last one, 4 times 36. We have 4 times 36. Well, 4 times 36 is 144. Square root of 144 is 12. Well, if the pattern continues, this one also should come out to be 12. Square root of 4 times the square root of 36 is 2 times 6, which is 12. Again, notice I got the same answer. So what does this tell me? This tells me that the square root of A times B and the square root of A times square root of B are the same. I'm allowed, if I have the square root of, let's do 9 and 3, to split this up as the square root of 9 times the square root of 3. Or I can reverse it. If I have this, then I can put it together. Kind of keep in mind that if you are on the inside, if you're in jail, you're part of a group. You can go together. It's the main concept. If you're in, you're in. It doesn't matter which radical you're in. If you're out, you're out. Okay? You're either kind of going to jail society, you're either part of a society or you're not part of a society because you're in jail. So you're either in jail with all the other people, or you're not in jail, so you're out of jail with all the other people. So we're going to use this concept when we're simplifying and multiplying our radicals. So here I have 5. 5 is out. 300 is in. So I don't need to do anything with the 5 because that one's already out. But I need to see if anyone can join the 5. So I have 300 is 30 and 10. Simplifying this down is 6 and 5. 2 and 3. Again, it helps to circle them so you don't lose them. 2 and 5. So on here I have a pair of 2's and a pair of 5's. So I have 5 who's already out there, another 2, another 5, and then the 3 got left in. Well, 5 times 2 is 50, square root of 3. So on B, 3 is already out. I need to see who can join it. So I square root of 125, which is 5 times 25, and 5. Since it's a square root, I just need a pair. So a pair of 5's join the 3, so that's 15. 3 times 5. And then 1 5 got left in. So on C, notice these are both inside. So they're both part of jail, so they can be put together. And since it's multiplication, I can multiply these two together. Or there's another strategy you can use, which I will actually use on the next one. So I'm going to show you two strategies. You can pick whichever way you want. And there's probably a couple more, but these are the two most common ones. So you have 6 times 15. So I can multiply. This is the same thing as 6 times 15. Well, 6 times 15 is 90. Well, square root of 90 breaks down to 9 and 10. 2 and 5 are both prime. 3 and 3 are both prime. So 3 gets to go out. 10 has to stay in there from the 2 and 5. Now, the other strategy you can do is that you can just leave them separate and then combine, because they're both in jail, so it doesn't matter where the numbers are coming from. Here we just put them together. So 13, well, you can try to break down 13, but 13 is prime, so that's 1. And then I can break down 52. 52 is 4 and 13. And then 2 and 2. Alright, so then I can match up. I have a pair of 2's. And then I have the 13 from here and the 13 from here, because again, they're both inside, so I can put them together. And then nobody got left inside. Well, if you don't have anybody in jail, there's no need for a jail, so we don't have it anymore. So I have 2 times 13, which is 26. So on E, notice I have a root on the outside, and then I have an expression on the inside where there is a subtraction. So in this case, this is like if I would give you 3 times 2x plus 4. And hopefully you know that to simplify this, you would distribute. Well, I am going to distribute the root 2. So I'm going to distribute it to the 5 and distribute it to the root 8. So I have 5, which is out. Root 2 is in. So I can't multiply these two together, because remember, either out or you're in. So this is 5 square root of 2 minus. Now the 8 is inside, so I can go root 2 times root 8, which is root 16, and then I got the minus sign because this is like a negative 1. Simplifying 5 root 2, that is done. I can't break down root 2, but 16. If you brought your A game, you can recognize the square root of 16 is 4. Or you can break it down into 4 and 4, and then you get 4 2's, which is 2 times 2, which is 4. So 5 square root of 2 minus 4. Knowing your perfect squares is a time saver, trust me. So F. So here I'm distributing the 2. So 2 times 2, which is 4. I can multiply these together because they're both out. And then I have 2 times square root of 3. This is out. This one's in. I can't put them together, so this is plus. 2 stays out. 3 stays in. That one's done. I gotta check to see if my roots are simplified. It is. So you are all finished with that problem. Alright. Last two examples. Again, I'm going to be distributing. I have a root 3, which is in. And first I'm going to multiply to 5 root 2. Well, 5 is out. Root 2 is in. So I multiply together who's in together. So I have 5. 3 times 2 I can go, so that is root 6. Minus 2. 2's on the outside, 3's in, so I go 3 times 6, which is root 18. Alright, can't stop there. You always got to check to see if you simplify. You have 6, which is 2 and 3. No pairs, so that one is done. I can root 18 is 9 and 2. 3 and 3. If we have a pair of 3's, we got a 2 that got left. So it's 6, joins the 2, root 2. These two cannot be put together because they are not alike. They do not have the same root. Alright, last example. Now I have 3, which is out, and root 2, which is in. And I can multiply it to each one of these. Well, 3 has nobody on the outside here, so I just have 3, or there's a 1. There's always an invisible 1. Times 2 times 24, which is 48. Plus 3. Oh, there's another outside number, which is 2, so those can be multiplied together. And 2 can be multiplied with what's under the radicand, which is 12. So 48 is 4 and 12, 3 and 4, 2 and 2, 2 and 2. So I have two 2's that go outside, so 2 times 2 times 3. This is 12. 2 times 2 is 4 times 3. And then I had a 3 that got left in. Over here, I have 4 and 3, and 2 and 2. The 2 joins the 6, that is 6. Square root of 3. Well, in this case, can I add these two together? Yes, I can, because they have the exact same root. So this is 18 square root of 3. Alright, so just to review, remember you're either out or you're in. You're either outside of jail or you're inside of jail when you're multiplying together. So if they're both out, you can multiply them together. If they're both in, you can multiply together, but you cannot combine the two. Check to make sure all your radicals are simplified before you're done with the problem, like we did in the last examples, and then add like terms if necessary. Just a reminder to do your reflection so you get credit for watching this video.